In this video, we're going to talk about the techniques that we have for evaluating limits. The first technique that we have is called the dividing out or factoring technique, and below is an example of what one of those might look like. So notice that we have a limit of a rational function, and in this rational function, the problem that we have is that if I were to try direct substitution, if I were to take this -3 and plug it in for x, the result would be 0 in the denominator. And that's something that we can't have happen. So what we have are these techniques to get around that. And in this technique, our goal is to cancel something out or divide something out to simplify this and then re-plug it back in. So let me get rid of this real quick and I will show you how to do it. So what I do know is in the numerator, I can factor x squared plus x minus 6. So we're going to set up our two sets of parentheses. My denominator is still x plus 3. That's not going to change. And we need to find factors of 6 that yield a positive 1, which is right here. So our factors for 6 are 1 and 6 and 2 and 3. So which pair could we possibly add or subtract together to give me that middle term of a positive 1? And their solution is going to be the 2 and the 3. We just have to decide what signs they get. And if you're not sure, then we can always start our binomials by placing in our x's, okay? And then we can put our 2 and our 3 in here. And we can kind of decide our signs as we go along. So from what I can tell, the only way that I can make 2 and 3 add up together is by having a positive 3 and a negative 2, because that will add together to a positive 1. And if I multiply them together, negative 2 times positive 3, I get negative 6. So we're set. And the goal here, or what should be happening, is that something should be able to cancel. And sure enough, this x plus 3 and this x plus 3 in the denominator are going to cancel completely. And all we're left with is x minus 2. So once something cancels out, you want to try plugging your limit back in. So sure enough, if I go ahead and plug in negative 3 here, which is what we were approaching, and subtract 2 from it, I will get a real number, which is exactly what we want. And in this case, it's negative 5. So that's going to be our limit. Okay, so here's our next example that we're going to take a look at. This is the limit as x approaches negative 2 of 2x squared plus 3x minus 2 over x plus 2. And just like before, we're going to try our direct substitution. There's actually one thing I want to show you specifically in this that you may not have seen before. If I go ahead and replace all my x's with negative 2 in this problem, I actually get 0 over 0. And this is a very special case. We call this form indeterminate. It's actually a form that we really can't do anything with. So, big problem. We got to do something to get around it. And in this case, we're going to try factoring, because if I look in the numerator, that definitely looks factorable. So what we're going to do, since the coefficient of our x squared is not a 1, it's a 2 instead, we have to do this by another technique. We can do this through quadratic formula, we can do this through synthetic division, we can do this through several multiple options. I'm going to do this by grouping. So the way to do grouping is I'm going to bring down that entire numerator just by itself so I can work this out. And we want to take a look at the first and last terms and multiply them together. So that's 2 and 2. Don't worry about it being positive or negative. We'll take care of that when we put our signs in our binomials. So 2 times 2 is 4. So I'm going to list out the factors of 4 this time to give me my middle term of a 3. And our factors for 4 are 1 and 4 and 2 and 2. And the only pair that's going to be able to give us a 3 is the 1 and 4. So we just have to kind of decide what kind of 1 and 4 that we need. And it looks like since my middle term is positive, that the larger number has to be positive. So that's going to be positive 4 minus 1. Now, what we're going to do is we're actually going to rewrite this whole thing, and instead of writing 3x, I'm going to write 4x, which is positive, so it gets a plus, and minus 1x, or minus x. And I'm just going to bring everything else down. This is how we do what's called factoring by grouping. So this is what we now have. And after you do this step, we are going to group together the first two terms and the last two terms, hence the name factoring by grouping. So we're going to look at each binomial and take out whatever they have in common. So in the first binomial, I have 2x squared plus 4x. It looks like they both have a 2 and an x in common, so we are going to factor that out and figure out what goes back inside. So it looks like I'm going to need an x here, so 2x times x is 2x squared, and then plus 2. And please remember that if you're ever unsure if you have factored correctly, just distribute back and you should end up with what you started with. Okay, so we're going to go ahead and do this to the next one as well. And I see negatives in both of the x and the 2 term. Also, a good rule of thumb is if your first term here is ever negative, factor the negative out. It's going to make this a whole lot easier. So I'm going to take out a -1, that's all they have in common, which means I need to have an x plus 2 in the inside. And of course, again, you can check by distribution. Now, you will know if you did this right if your binomials end up identical, okay, which is a good thing. So what that means is that's going to be one of my results. So I'm going to have x plus 2, and then the other binomial comes from whatever's left over. So this 2x and the -1. So this is what I'm going to replace my entire numerator with, okay? So everything all together now looks like x plus 2 times 2x minus 1 over x plus 2. And remember, our goal is to get something that cancels, and sure enough, the x plus 2's do. So we're going to retry plugging in our limit. So we're left with 2x minus 1. We're going to plug in -2, since that's what we're approaching. And it looks like that's going to also give me, let's see, a -5. Yeah. So that's going to be our limit. All right, so here's our last factoring problem that we're going to take a look at, and then we're going to move on to the second technique. So we have the limit as x approaches 1 of x minus 1 divided by x cubed minus x squared plus x minus 1. And this is also a unique situation. In the denominator, we have 4 terms, so we can't actually use any sum or difference of cubes formula. We really can't do anything super special. So what we can do, though, is just like in the problem before, we can factor this again by grouping together the first 2 and the second 2. And of course, the main reason is when I plug in 1, I'm going to get 0 over 0. I'm going to get an indeterminate form. So to start this, we are going to work on just the denominator, so x cubed minus x squared plus x minus 1. So there's our first group, and here's our second group. So we're going to take out whatever the first 2 have in common, which looks like it's going to be an x squared. And it looks like what's going to be inside is x minus 1. And then in the next one, the only thing that I can take out between a positive x and a -1 is a 1. And it's a positive 1 because this term is positive. If it were negative, take the negative out. So the only thing that's going to be inside is the same exact thing, which is good because now these 2 are identical, which means we did this right. So that's going to yield one of the binomials, x minus 1. And whatever's left over, the x squared and the positive 1, are going to be the other part. So we're going to completely rewrite the limit. We're going to have x minus 1 divided by x minus 1, which is good. Those are going to cancel, and x squared plus 1. So we're going to go ahead and cancel those. They're gone. And what you're left with is something over x squared plus 1. And if you're ever left without anything in the numerator, it's just going to have a place value of 1 to just make sure that it's a fraction. So again, we're going to try to plug in 1, since that's what we're approaching. And it's not going to cause us any problems this time. So we're going to have 1 squared plus 1. That's 1 plus 1, which is going to give us a limit of 1/2. And that is how we do our first technique of factoring. So our second technique is called the rationalizing technique, and we have been rationalizing quite a bit already. So this is going to look somewhat familiar, but there's one small twist to it, and it's a way to, again, get around an indeterminate or undefined term. So let's take a look at an example and see how that's supposed to look. So here's an example of something that you would use rationalizing for. Now, we have only been rationalizing to get radicals out from the denominator. However, we can switch that idea around if we are in this particular situation and we need to change the way that it looks so that we can plug in our 0. Please notice, too, that if we went ahead and plugged in 0, we would, again, get an indeterminate form. So what we're going to do is, first of all, make sure that we understand what a conjugate is. And a conjugate is just the same exact two terms with different signs. So the one place that we can change is this numerator. And the reason is because it has the square root and it's being added or subtracted to another term. And it can be a 1 or a 10, or it could be another root. Either way, this technique will help you get rid of them and help change the way that it looks so you can try to plug your limit back in. So the conjugate of this numerator would be the exact same two terms, x plus 1, and a 1, except that there's a plus instead of a minus. And the reason why this works is because we're going to multiply these conjugates together. We're going to take this and multiply them. And what that actually does is it creates a difference of perfect squares. So when we actually FOIL this out, okay, let me show you the whole entire thing so you can see what it looks like. If I multiply the first two terms together, the root of x plus 1 times the root of x plus 1, I am just left with x plus 1. Okay? Now, the outer and inner part is where this really gets interesting. If I do the root of x plus 1 times this 1, I get a positive root x plus 1. If I do the inner parts, the negative 1 and the root of x plus 1, I get minus root x plus 1. And what you should see, what's cool about this is this and this will completely cancel. And this will happen every single time that you multiply by a conjugate, which means you do not have to worry about ever doing the outer or inner parts. You only have to worry about multiplying the first two terms together and the last two terms together. So of course the last two are negative 1 and positive 1, which just gives us minus 1. So our entire numerator just turns in to x plus 1 minus 1. Now, whatever you do to the numerator, you must do to the denominator. So when we do that down here, we don't necessarily have to distribute or FOIL. We want to see if something might cancel first before doing that. So leave that as the last thing that you do. So we're going to multiply the denominator also by a root x plus 1 plus 1. And I'm just going to rewrite it. So this is x times root of x plus 1 plus 1. Okay. Now we want to simplify and see if anything cancels. That's the goal of both of these techniques. So notice in the numerator the positive 1 and negative 1, they're going to cancel. We have now just an x up there, and everything else gets rewritten. And now what's going to happen is that the lone x's here are also going to cancel. So they're gone. And now all I have left is a 1 up in the numerator to make sure that it stays a fraction. And then I just have this root x plus 1 in the denominator. Now, as soon as something cancels, like something big like this, especially a variable, you want to try plugging your limit back in. Okay? So I'm going to try to plug in 0 and see if I don't get an actual number. So we're going to do 0 plus 1 plus 1. And of course, this is just 1, and the root of 1 is 1. So we have 1 over 1 plus 1, which is equal to 1/2. So sure enough, it worked, and we're good to go. So we're going to take a look at one more example like this, and then we're going to wrap this up. All right, so here we're going to have the limit as x approaches 0 of the root of x plus 3 minus root 3 over x. And of course, we plug in 0, and we get indeterminate again. So the part that has the roots, the part I know I can change is going to be the numerator again. This is actually its proper form. So we're going to try to move all the radicals back into the denominator, and hopefully that will help. So we're going to go ahead and get the conjugate of, in this case, the numerator, since that's where my roots are. So again, we're going to just bring over the same two terms, x plus 3 and root 3, and we're just going to change the sign in between them to a plus. And whatever we do to the numerator, we must do to the denominator. Just like so. And remember, we only have to worry about multiplying the first two terms together and the last two. So these two and these two. And then we're just going to rewrite the denominator. So that's going to become, just going to write our fraction bar. I'm going to go ahead and just rewrite our denominator real quick, since we're not going to FOIL that out or distribute or anything, at least not yet. Okay, so now in the numerator we have the root of x plus 3 times the root of x plus 3, which is just x plus 3. Those roots are just going to cancel. Now I have a negative times a positive, which is going to give me a negative, and then root 3 times root 3 is just 3. And it looks like in the numerator that positive 3 and negative 3 are going to cancel. And also, the x's are going to cancel as well, because once I just have this x and this x, they're also gone. So if you guys want to, you can skip going over through multiple steps and rewriting if you can see this all at once. If not, just rewrite this as many times as you need to make it easier for you. So I need a 1 in the numerator since there's nothing left there, and all I'm left with in the denominator is root of x plus 3 plus root 3, and of course something just canceled, a variable canceled, so we want to try to plug our 0 back in. So 1 over the root of 0 plus 3 plus root 3. And that's going to give us altogether 1 over root 3 plus root 3. And now if you're a little rusty on adding radicals, it's just like combining like terms. They have to be the same exact radical. In other words, what's under them has to be exactly the same, and then you just combine them. You see how many you have total. So notice that I have 2 of them. So I'm going to write this as 1 over 2 root 3. And for the purposes of this particular problem, you can leave your answer in an unrationalized form. If that's bothersome to you, which to me it is because it's not rationalized, all you need to do is multiply the top and the bottom by the root that needs to go away. And that would leave us with root 3 over 2 root 3 times root 3. And of course, these two combined is just going to give me a 3. So this all together is 2 times 3, which is 6. So altogether, root 3 over 6. Either way is okay, but this is way more formal. Okay, so that's it for your techniques of evaluating limits when you have indeterminate forms, and that will conclude this tutorial.